So most of the time the experiments they do in machine learning, they use board games, either chess or checker games, because as it written this, it's understandable. People can understand that how chess game works, and it is complex also at the same time. So because of that reason, most of the time these researchers they use board games to see how the artificial intelligence works. Okay, so after that.
So you already have few man versus computer games, right?
Mm-hmm.
So those obviously don't use machine learning.
Not all of them. Not all of them. Some
Not
of them.
all of them.
Not
So
all of them.
when you tell you're using machine learning in board games, so is it becoming clear perspective ki, okay, this guy is playing against me, I take these moves, or this guy? That additional customization is there, is it?
Okay, that thing is also there. I'll say that, let's say that there are two people playing chess game only. So if two people are playing, these top level people, before they go for the chess game, the night before, the day before, they do preparation on the opponent, right?
Correct.
So you can make this machine learning or artificial intelligence chess games also, which can be specific about that certain person. Maybe they'll go through the matches, all the previous matches he has played before. He'll try to understand his pattern also. So, those
that personal touch comes in via machine learning.
Yeah,
or else it can be a general computer, some algorithm which takes the best move what he has played.
If I go through the time frame till the year 1990, 2000, so that was knowledge based. It was not like every move they are not able to improvise. So now, because of the use of machine learning, so go back to it.
Saying what I really are.
कुछ बोल रहे थे हाँ. So right now they can improvise also. Maybe during that time, 1990.
Or else it would be normal games without machine learning where you pick up the best move, that's it. It's not machine learning in that.
Yeah.
It is more statistical.
It's
statistical.
I'll come there. So after that, there is something called the perceptron. So I want you people to, maybe the people who will be interested for the next sessions to remember, I'll tell few terms which are important terms. This perceptron, this is one very important term. Is being used everywhere now in neural networks, or the most basic term which is perceptron. So before I get into this, I'm going to talk about this guy, Donald Habs. So here's this researcher kind of people. So what he was trying to mimic, or he was trying to understand how our brain works. So like in our brains we have neurons, right? So from neurons, one signal goes from one neuron. So how information passes from one neuron to another neuron. So he was trying to understand those things, and based on that he has written a paper. So this guy, Frank Rosenblatt, so in the year 1957, he combined the ideas of this previous world idea, this checker game. So the guy, what he has done, and the idea of this Donald Habs, he came up with one model or one algorithm which is known as perceptron, which is the backbone of recent or this current machine learning. So perceptron. So how perceptron is, it looks like something like this. You see there? So basically the most basic part is perceptron is, let's say if I give something input, it has to predict some output, and there will be some inner layers in this. So if I explain it this way, then it will be here. Let's say I have y equal to a, x0 plus b, x1 plus c. So if I have some input, this x0, x1, and based on this input, I will be getting this output. And this a value, a, b, c, these below certain values which will be fixed. So in our case, what basically most basic form the machine learning does, machine learning actually basically tries to understand or try to find the value of a, b, c. What will be the best values of a, b, c so that if I give these inputs, we get the expected output. Like, is it understandable what I said, or like I should repeat again? Got it right? Okay. So this A, B, C, this is nothing but these three boxes, and these are inputs. So it can be multiple, right? Here x0, x1, x2. It can be x to the x100 also, xn also. Same whether A, B, C, T, and whatever it is. So this is the most fundamental block of machine learning. I won't go deeper right now. Next sessions you'll get to know more about it, and that will be interesting. So yeah. So this A, B, C, these three things, they are the parameters which you have to find out. Also, basically that time when people didn't have machine learning or proper understanding of machine learning, how it works, they used to sit, this image processing scientists, and they used to sit, they used to do research, and finally they used to find out what should be the best value of A, what should be the best value of B, what should be the best value of C, and based on that they used to decide the equation or whatever it is. You can see that. Is it like little bit understandable what I say? Is it making sense, right? Okay. So he was the guy who came up with this idea of perceptron. So that's that.
MDA बोल रहे थे तुम लोग.
Yeah, but the thing was, so to find this A, B, and C values, that is very much time consuming. So, and people have realized that using that thing, they actually try to find some visual patterns. Though it looked promising initially, they tried to find visual patterns. Let's say in face recognition also, they're trying to find visual patterns, but they're not getting any significant results because of the way they're used to finding A, B, C values. They are not efficient, slow. So that was the reason. So that was the reason. Maybe the researchers, they're trying to do something, but because they're not getting any fruitful result, the investors, the people who used to fund for these projects, they slightly moved away from these fundings. So they were not getting any results out of it. So, and because of that reason also, most of the machine learning scientists also, they thought that there is no future in that. They moved to different fields, other sections of computer science, and they succeeded in those fields. But there are a few people who thought that like they had from the childhood only they wanted to do something. So there is a guy, I'll talk about this guy. So he thought that I'll stay back. So he was thinking that if brain can work, then machine also has to work. That was his thinking. So he stayed back and he did some on his own research, and he finally came up with something. So that is the revolutionary idea which changed everything. So I'll come there. So yeah, that was the thing. So that's 1970 and 1980. That was the depression period. They are not getting anything out of the thing. So it was just going on. No fruitful result was coming. And then this is the age of this particular time, 1986. So this another term, backpropagation. This is very important term in machine learning. We'll go through that also. That will be very interesting. So yeah, so that is, so now see, I told that A, B, C, these are the parameters the scientists used to sit and then they used to find out. But because of this backpropagation, because of this algorithm, people found a way to find those parameters using machine or like using calculations. Not you have to do it manually. Automatically also you could find this A, B, C below. So that is the like revolutionary idea in machine learning, this backpropagation. And there is this guy, Hinton. This is very prominent figure in machine learning field or AI field. And these are the two other guys they came up with this research paper, which finally able to solve this problem, finding the A, B, and C values using auto process, not manual process. So, and then after that there was another guy, Jan LeCun. He's also a very pioneer in machine learning, and he worked on something named convolution neural networks. This is also another very important topic. So in our coming sessions, we'll have one dedicated session on convolution neural networks. We'll talk about a lot about backpropagation also in this session. So just remember this term. So when you come to those sessions, you will just think that yeah, that is like you'll be able to connect. So yeah. So these two people, they have written that. So this guy, he has written his PhD thesis on that particular using backpropagation in convolution neural networks. So this is important term. Just remember that. So yeah, that was the thing. So if you see this, this is one of my favorite memes. So G. Fontaine is the guy who came up with backpropagation. So if you see this meme, G. Fontaine after writing the backpropagation paper 1986. So just hi guys. you guys aren't ready for that yet, what it's gonna come up with, but your kids are gonna love it. So now 95% machine learning algorithms are using this paper version, which is so important, and it's very interesting also. Okay, so if you go to the next then, and machine learning application. So the thing is, though they found some revolutionary idea to use machine learning, but the complication there was to do those calculations, the kind of machine power, computational power we needed that time, we didn't have that power. So the good amount of research was going on, but still they're not able to get desired result out of it. So that's the reason till 1990 also it was stagnant kind of, the machine learning. It was just going on, no fruitful result was coming on. So after that, this machine learning application 1990s. So then at that point in time, if you people know that internet also came that time. So a lot of data was coming. So people had the access of data. So what people were trying that time, that so there is a written that shifted from knowledge-driven approach to data-driven approach. What does that mean? So knowledge-driven approach is something like if you go to data structure algorithm. So it's like knowledge-based. We know that this is the algorithm I have to follow, and based on that but data-driven means it's not based on, so there will be one algorithm which will be manipulating the data or working on the data, but the algorithm will be dependent on the data. So based on the data, it will be changing the things. I don't know if it makes sense or not. Okay, on the way you get to know more. Okay, so that point of time, so people 1990, that was this 1990 decade, they're basically trying to find patterns in the data. They're trying to find trends in the data, what is happening. So data mining and everything, you just get to know about this.
I have a nice example. I can, if you want me to.
Yeah, sure.
I have a very nice example. So there is a term called, for an example, there is something called, pardon my handwriting, it's ACES. Do you guys know what it is? ACES. Nobody knows what it is. Okay. So let's make it. What I am going to do is, you guys don't know what this term is. Okay. I'll give you a few examples. Humans are aceless. This is the first example. Okay. Dogs are aceless. Okay. Cows are not aceless. Deer is not aceless. Parrots are aceless. Okay. This table is aceless. Okay. Cool. So let's say I give you 10k examples of this thing, and maybe 10k other examples of this thing. I'm not telling you what an aceless thing. What is this aceless? I'm not even telling you. Okay. But I am giving you sufficient examples. So what happens is, I think even our brain does this thing the same way. Like there are so many things you don't know the terms about. You don't know what are they going to be. But because you have examples around them, like driving. Driving is something we have a knowledge-based system also. Like somebody will be there who will tell you, okay, you have to use this clutch and you have to do this and blah blah blah. But if you don't have anybody, let's suppose you don't have anybody who tells you how to drive. Over the period of time, you will just try it and just start driving. You learn things. Okay, this is going to work in this way. This is going to work in this way. So the same thing is this is what is called a data-driven approach. The thing that he is explaining over here. What will happen? If you feed this information to a machine, it will actually try to figure out patterns or some structure or some characteristics in this set of data that's common along the examples. Okay, these are the examples. I'll tell you what that characteristic is. It will just try to figure out something that's common in these things. These values are those things. Okay, so system will actually try to figure out these values so that this equation works fine for this set of examples and doesn't work for this set of examples. This is the aceless thing, this is the non-aceless thing. Okay, so getting these values A, B, C, the data-driven approach that he is talking about, where you feed the data. You don't know what it is. System will never know what an aceless is. But it will be able to actually classify this aceless when you give the system a new example. I given it 10 keywords here, 10 keywords here, but let's suppose I didn't tell what a fan is. But because I fed him these 10 keywords, if I ask the system what a fan is it an aceless thing or is it a non-aceless thing? It should be able to tell me that it's a non-aceless thing. Okay, so system doesn't know what an aceless is, but just because of these examples, it has figured out some characteristic, something that's common among these examples, and now it's using those characteristics to actually classify a new thing. That's what it is a fair. Actually, aces is nothing, it's just the animals or the human beings or whatever you call it with the horns. The people, everything that have horns, tentacles are aces. Who doesn't have, those are non-aces. It's a simple classification problem. But system will never know that something with horns is aces or something without horns is non-aces. It will just figure out a characteristics like in form of mathematical terms like A, B, C, these values. It will just figure out a set of A, B, C's, but it will actually define this particular characteristics indirectly. Directly it won't know this thing. This whole approach is data-driven approach that he is talking about. There is no algorithm around it. There is no predefined algorithm way. You do this first step, second step, you do this. There is nothing around it. You just feed the data to the system and system figures out some characteristics inside.
So if it figures out some other characteristic which is not intentional.
Yeah, sure. So the backpropagation thing that he's talking about, that thing will take care of that particular thing that you're talking about. So backpropagation is nothing, it's just testing yourself, like how humans do. Like how does a child start walking? He just starts walking, he fell off. Then he figures out that if I do this way, I just fell off. He won't do that next time. Getting a point? Okay. So it just automatically corrects itself depending on the input data that you feed it.
So it's us to decide. Basically, you give it a word. Now you know it's a non-acerus thing, but it by chance classified it as a acerus. So that time you correct the machine.
Yeah.
So it's a iterative process.
Kind of. There are few more things around this whole scenario. Like there are a lot of things around this whole scenario. How does it automatically correct itself and go through that process? There are other things around. I'm just citing this for the sake of example, so that you actually understand this data-driven thing. Because the whole the neural networks and the ML part, the ML is nothing. It's just a data-driven approach. Like we had all these techniques before in hand, all these statistics, all these algorithms. Like you have a simple XOR gate. Gates. Do you guys know about gates? A simple OR gate. You know that the 0 0 is 0 and 1 0 is 1. Huh? I'm not talking about gate. I'm just telling them you can understand that. Hey, I'm just talking about the machine can figure that out.
So that is really good example. The way I wanted to explain.
But I know the human is not as
Okay, so yeah, that is good example. So in fact, related to that only, there are 2-3 algorithms which we are going to cover in first or second session. So yeah, these are linear regression, logic regression. I'm just giving the terms so that next time you can relate. So after that, there comes this. How many of you know Gary Kasparov? He knows Gary Kasparov. Okay, so he is considered as the legend of chess game. He's one of the best chess players considered throughout the world till now. So whatever the research or outcomes, results which are coming from machine learning, that was not popular in the general public. They didn't know about those things. So what happened in 1996? So IBM people, they came up with one machine. So the machine was, they said that it can play chess game on its own. So and then they challenged Gary Kasparov. There is a machine. So we believe that this machine will be able to beat you. So they challenged him, and then there was match happened. So what happened in 1996? There was one match. In that match, there were 6 games. The first match, the machine was able to beat Gary Kasparov. So can you think about this thing? 1996, there was a machine who was able to beat the number 1 chess player in the world at that point of time. So that made a huge cry in the crowd that how can some machine can beat Gary Kasparov. But what happened in the game? In that game, finally Gary Kasparov was able to win 4 matches, and there was 1 draw or something like that. So final result was 4-2. Gary Kasparov won the match. So people were little relieved that machine is not competing with human. Like it's not at least above human. So 1997, what they did, these IBM people, they upgraded the version. They call it Deep Blue. Initially it was Deep Blue, and then they changed the name to Deeper Blue. And they upgraded the version. So, and again they asked Gary Kasparov, and again he came, and this match happened. So final result was 3.5 versus 2.5. Finally, machine won the match also, not in a single game. They won the match also. And for that particular machine, what it used to do, for every move, for every chess move, it used to think 6 moves to 20 moves beyond that particular move, and based on that it used to take decision. And for doing that, this particular machine used to, like, it went through thousands of old chess games. So that much of work it has done, the machine learning, this machine, to finally this beat Garry Kasparov. But the method that was used for this machine to work, that was not fully this mainstream machine learning or artificial intelligence we are working on right now. They somehow use the mixture of knowledge based as well as the data driven. But so finally, when the match got over, there was this Garry Kasparov. He accused IBM of cheating. I don't know what happened in that. You people can go. There is a documentary also, so there is a YouTube link about this whole documentary. You can go through that. There is a nice documentary. You people will like it. So there was that thing, but there was one incident happened that made popular machine learning among the people. So, and then there comes modern machine learning. So I told you these people, right? So because of the fund reason, a lot of people left interest in this machine learning. But there are a few people who thought that they'll be able to do something. They are still working on. So remember I mentioned this guy Hinton. There's a meme also about that Hinton. So he was still working on that thing. 3 decades. He was not getting any fruitful result, but also he stick to that. So he was working on that thing. So when he was working on this machine learning things, he has his own students also, right? So he was asking every possible investors to invest money on his research, so that he can get something out of it. But he was out of funds. He was not getting any funds. And then finally he got one proposal from this military, but he didn't want to take the military investment. The reason behind not taking military investment, because if you work on some military, they don't be open source. People, this kind of people, they wanted to share their knowledge, right? So he didn't take that. Finally, one organization from Canada, there is Canadian Institute for Advanced Research, CIFAR. So why this CIFAR is important? This organization has contributed a lot, invested a lot in the field of artificial intelligence. So they have good kind of contribution in the field. So they finally came forward and they said that we'll give you some amount of money. So they asked him to form a team. So what they have done, so this Hinton, and there is another guy, the guy I mentioned before, Ian Lecon, and there was another guy, Bigion or something. Benjamin. Okay, so this guy, so all they came together, and what they have done, they formed a team. In that team, they invited mathematicians, they invited neurosurgeons, neurosurgeons also, psychologists, all these people, and they started working on these things. But the best thing, that was the time our computational power also increased. So maybe in the year 1980, 1990, the kind of computational power we had in terms of CPU, it increased exponentially. Everyone knows about the Moore's law, right? Exponentially it increases. So that was the one fruitful time. Everything was in the favor. So that worked so good for them. Finally, they were able to utilize or apply all those algorithms they had, and they started getting results also out of it. There was so good time that all the artificial intelligence competitions used to happen. This group of people used to participate in that. They used to win the awards for that. So there was. So he said that this is the phase that machine learning again rebooted, and after that it rebooted and it never stopped. It's still going on and going strong. So trust me, it's gonna go strong future. So, and there is one thing, and then there is something called LXNet. So why this is important, this LXNet? So till this point, 2006 to 2010, what people are doing competition on CPU. CPU competition is nothing but serial competition. So people are doing research on GPU. GPU means graphical process unit, but what it basically does, it can do the computation parallelly. Instead of doing waiting for one operation to get over and then doing the another operation, we have GPU which can do parallel processing. So this guy, there was another artificial intelligence competition named ImageNet competition. This guy, he used the GPU, and using GPU and one big, so now that he is using GPU, so instead of using this x0, x1, x1, 2, if people used to use x100, because of this power, he was able to use x to the power 10 to the power, let's say 6 or 7. So because of all this increase in the parameters and all those things, he was able to get very, very good results out of it. So he won the competition way ahead of other people. So the competition, they judge the competition based on accuracy. So let's say that if out of 100, 90% of times you're going to get good results or correct results. Based on that, they decide that how good that model is or my AI is. So maybe it was something like his result was way ahead of all the other competitors. So there was one revolutionary thing also. So this is the guy. And then, so at that point of time, all those big giants, Apple, Facebook, Google, they realized that this is the time they should also invest in. Now they realize that, yeah, something is going to happen. So they started investing on those things, machine learning and research. So Google came up with, they formed a team named Google Brain. And Google Brain, that time they were working on this facial recognition, other recognition, detection algorithms, in fact in object detection in YouTube. So there is a YouTube link here. Okay, before that I'm going to show something. I forgot that. I told you people about the struggle of this guy, right? Hinton was struggling very hard. So there is a video about this guy. I want you people to see that.
He's the one who won.
70s, people said artificial intelligence was the stuff of science fiction and that he would toil in obscurity. Today, he's revolutionizing how we live. Joining us now to discuss the
Is
work
that
and what kept him going, here's Jeffrey Hinton, professor of computer science at the University of Toronto and distinguished researcher at Google. Nice to have you here at TVO.
Nice to meet you.
What got you interested in deep learning to begin with?
When I was in high school, I had a friend who was a brilliant mathematician who came into school one day and said, you know, in the brain, memories are distributed all over the brain. And so each memory is in lots of different brain cells. And that was a fascinating idea. And I just kept thinking about how the brain might work from then on.
Something about that idea planted a seed in you and you were off to the races. How many people were involved in this kind of thing then at that time?
Quite a few people were interested in it. And in the 1980s, neural networks were very big, and people used them for things like detecting credit card fraud. But then came the neural net winter. In the 1990s, they hadn't lived up to their promise, and most people stopped working on them. But you didn't stop. It seemed to me there was no other possibility. The brain has to work somehow. The neural networks are a simplified model of how the brain works.
Did people tell you, Jeffrey, you're wasting your time, think of something else to do?
Many times. When I was doing my PhD, my advisor would tell me that every week.
And would you say back?
I would say, well, give me another 6 months and I'll prove to you that it works. And every 6 months I would say that again.
Who got the last laugh?
It's not clear. He died before this stuff became successful.
I was going to say, I mean, here you are, all these, how many decades later, still working on this? So
4 decades later.
4 decades later. And it's a thing now, isn't it?
It is, yeah.
It is a thing. You are obviously, I'm detecting from the accent, not from Hearst, Ontario.
You can go through the whole video. I'll share that video.
What brought you
There
over
is
here?
like one nice Indian.
I went to the States first because I couldn't get a job in it.
Okay, for all those things I have attached links, so if you are really interested, you can go through the link. And then, yeah, I was talking about this Google Brain thing. So they started working on the machine learning Google people, and there is DeepFace. DeepFace is nothing but there is another team from Facebook. So you remember 2014-15, there was Facebook, they came up with a new feature. So once you upload a photo, they used to give suggestions that you are going to tag your friend for this particular face. There was a feature came, right? So that was done by DeepFace that time. So that was one cool feature that came, right? So, and then DeepMind. So DeepMind is another company. So they started as a startup and finally Google acquired them. So what they are doing? So what I said, no, what they are working on, they are trying to play basic video games to some level, and they are able to succeed. They are able to succeed in that thing. And the best achievement they got 2016. So they made one program named AlphaGo. So in this AlphaGo, finally it was able to same way. So AlphaGo is a kind of board game which is much more complicated than chess. So and this AlphaGo finally was able to get the best champion from the world. So there is a video about this thing. This is also very interesting video. I want you people to go through it.
For decades, human beings have played games against computers. At first, computers struggled, but then they started winning.
Watson, what is greed? Yes.
And now they've become so dominant that they're raising doubts about the future of humanity. The latest emblem for existential dread is Google's DeepMind project, which created AlphaGo, an AI program that's become unbeatable at the most complex strategy game on the planet. While the game of checkers has 10 to the power of 20 possible outcomes, and a game of chess has 10 to the power of 40 possible outcomes, Go has more than 10 to the power of 80 possible outcomes. AlphaGo is trained to analyze situations itself by breaking the game down into tiny parts and visualizing all possible moves. Last week, it played the world's best Go player, 19-year-old Ko Jin, with the help of a human handler. AlphaGo beat him 3 times, and after doing what it was designed to do, retired from the game.
在这次比赛完之后，在他继续又不停的进步之后，我觉得他对我而言就是100%。
If a system like AlphaGo can learn all the moves in Go well enough to beat a person, then it has the potential to replace lawyers and accountants among dozens of other jobs. It might be perfect, but it has no way to navigate human politics. The Chinese government banned the live stream after Jert lost the first game. The loss to an American company was an attack on the country's pride.
The Chinese government has made a big effort to proclaim that they are moving ahead rapidly in artificial intelligence, that they will be the people who dominate AI. To have the dreaded Google come in and beat China at its own game, it's just piling insult on top of insult. It's kind of amazing.
But it was more than a national crisis.
对我而言就是个围棋的上帝。阿尔法狗出现之后，可能真的我对人生啊，包括不是你的围棋，对人生啊也有巨大的一个改变和看法。
You guys know this guy? The next thing is OpenAI. There was another non-profit organization which was founded by Elon Musk. How many people know about OpenAI? So they're also trying to make safe artificial intelligence which won't harm human. So when he founded, 2015, right? So at 17, and I think he decided that where the artificial intelligence is going right now, he was not happy with that. He realized that, or he thought that is not safe for the human being. So he came out of this organization, but the organization is still going on. So what they have done, so you people know about Dota game, right? So Dota game, so this year only March, so they made one program, these people, this team of this OpenAI, which was able to play Dota game against human beings. So what they have done, there is the world champion that time, for this year only, same year. So world champion, they played against this machine which was developed by these people for playing Dota game, and this machine was able to finally beat the human champion. So there is the result of that thing. And so it's mentioned here that for learning the game, OpenAI 5 plays 180 years worth of game against itself every day, learning by self-play. So it has so much competition happened, so much work happened inside that it played 180 years of Dota game to finally able to learn that how to play against the game. And for that thing, they're using reinforcement learning. That is also another topic which is not included in the session because we also don't know.
What is the difference between this and a bot?
Which
OpenAI who's playing Dota and any other bot in the game. So like we had bots playing.
Which bot you're talking about?
Like any game may will have a computer playing the game, right?
Mm-hmm.
So how is this different from?
So if OpenAI or this what they call OpenAI 5 is playing against human, it itself is a bot only.
Yeah. So how is it like?
It's not different. It's a bot.
It's a bot.
But it can beat the topmost player itself.
Okay.
So
It's not dumb bots that you were using.
So bots in many things.
dumb
Right?
bots.
So
It's
if
not
you go to
dumb.
Amazon,
It's
the
not
customer
Zomato.
assistance
It's dumb
you get-
bots that you are talking.
The customer assistance we get, that is also a bot.
Okay.
The robot which is moving in our, like all these automatic robots, those are also bots, and this is also a bot.
Some of the PUBG bots. They run out of.
Even PUBG also there are bots, right?
So they are using ML for enhancing the player, the
PUBG.
PUBG. No, just any game. Are they using bots is using ML or is it like a pre-programmed type?
Obviously, they have to like this. That's a data-driven approach and knowledge-driven approach. So using knowledge-driven approach, you can't go far. Like if let's say that there is a bot which is to go from this part to the other part of this pixel depth. How many if-else conditions will be there? How many conditions will be there? How many circumstances? How do you take care of all those things? There will be millions and millions, infinite number of things. So that's where this data-driven approach comes in. You can't write conditions for all of them. Right? So, that was, I think, that was a big achievement in the field of AI and machine learning. And after that, at that point of Amazon and all this, they also realized that now everything is moving towards this artificial intelligence. So and this cloud thing was also happening going on. So what they did, they moved. So for these GPU calculations, right, we need GPU. Either we have to buy the GPU or what people do, they go to the cloud, they use AWS server, so that they can have one remote machine there in their server and they can use those remote machines. So Amazon, they realized the opportunity that people are going to use cloud server and this is going to, so they made AWS and they are giving these remote machines for the users. So right now, 50% of the work what is happening in artificial intelligence machine learning, in fact more than that, is AWS based, cloud based, not AWS. Cloud based, AWS, Azure and all these things. They're providing remote machines. So that's the thing. And then this is another milestone kind of achievement. This is called as YOLO. YOLO means right now people know that YOLO is you only live once. This is fun intended. So this guy is really funny guy. That guy who came up with this algorithm, I'll tell about him. So he came up with this. So this is real-time object detection. So to explain what is real-time object detection, there is a video. You'll understand it from there.
That's the official website. That's the official video.
And so
India की है, मुंबई की है. अरे मलाड की है.
okay, so I have given this link. You can go to his resume also. Very interesting resume. Have you ever seen any resume like this? He is using unicorn. Just go through the resume. It's really funny. I don't have time. So this is one revolutionary achievement, and then there is something called GAN. So this point, the artificial became creative also. So by creative, what I meant, that they started making something. So one kind of art, something out of some other different kind of art, which just never existed in the world before. So till now, when they are following the data-driven approach, they are actually following what was happening before. But this guy, there is this guy, young Goodfellow, he's a good guy. So he came up with this. So yeah, he came up with this algorithm. So you can make your own art or something, some creative art out of something. There is this guy I mentioned, Ian Lekon. So he mentioned that this is the coolest idea in deep learning in last 20 years. So there is so extraordinary kind of thing. So how many people, do you know these people here? These celebrity people, can you recognize?
I can recognize.
Huh?
Yeah.
He's part of some TV series, famous one.
So I tell that none of these people, they never existed in the world. So they never existed. So using GAN, people right now we're able to. So this is called as deepfake. I don't know if you have heard about this thing. There is last year only it became very viral something. This year also became
Last
something.
month.
No,
last
initially it gaya tha. Recently
अभी
they came up with better versions.
last month somebody launched an app on Android store. You can just take a picture and replace it.
So these are like created by machines. And so I mentioned all those names before also. This Jeffrey Hinton, Ian Lincoln, this Joshua Bengio. thing is, I talked about this Turing Award, right? Finally, because of their contribution, last year, 2018, these three of them, they won the Turing Award. So they finally got what they deserve. So yes. And one honorable mention, how many people know this guy?
Honorable mention.
Everyone.
So that means they have, in their lifetime, they tried machine learning once. So whoever studies the machine learning, they go through this course, machine learning by Andrew Ng. So this is the guy who popularized the machine learning in the student community. So because of him, his Coursera courses, people who are self-interested, they learn about the machine learning. So people, they follow, go through these courses to learn the basics. In fact, I went through that course, Ranjan went through this course. Gaurav.
Even I went through that. Even I went through that course. That was the first course.
Gaurav helped him build the course. Okay. So, how many people have seen this movie?
Come on.
Yeah. सबने देखा होगा. Something similar.
ये तेरे वो न्यूरल नेटवर्क मीम वाले पेज से उठाया गया.
हाँ?
न्यूरल नेटवर्क मीम्स वाला जो पेज है उससे उठाया गया.
अच्छा, so there is misconception because so in if-else blocks you know that these are the conditions and conditions are known, so based on that you write the conditions. But when it comes to machine learning, you are not aware of the condition. There can be, as I said before, also millions and millions of conditions. So what AI does, it understands the condition and based on that it takes the steps. So it evolves itself. It's not limited in the number of if-else conditions. So that is the basic difference. So what if people used to think, that is fully wrong. It's not if-else block. It can be like the conditions are going to change gradually, something like that. So that was the thing. And there is another misconception that some people think that someone was telling me that what is machine learning? Machine learning is nothing but like what you people do, use some libraries and then find the output out of that. There is nothing like there's nothing else to do. But that is not that machine learning is just not a library. Library is like making our task easier. Right? So, but apart from that also, we do a lot of research kind of things or our own things which to make this algorithm better, make it efficient. So it's not just about libraries. There are a lot of things inside. And this is the Venn diagram of artificial intelligence and machine learning. So this artificial intelligence, this is the whole block or the global set you can say. And inside that they have machine learning. So machine learning. So artificial intelligence, we can say that the machines which can pass the Turing test, we'll call those things artificial intelligence. If you go inside this machine learning, the algorithms which are using data-driven approach, you can call this machine learning. And if you go more inside deep learning, the people who are using neural networks or convolution neural networks, that is called as deep learning. So we'll cover these two things in our sessions. And for doing all those things, we take help from data mining, data science, and big data. So that's how the intersection happens in this derivation. So if people, so I know that people used to say artificial intelligence kya hota hai. So that will make our understanding better about artificial intelligence.
What is the primary difference between AI and ML?
So ML is basically a subset of AI. Right?
In what perspective?
So there are a few artificial intelligence also which can be solved using this knowledge-based approach. So I said before there is this stage game, right? Deep Blue. They not fully using. They are not using machine learning or artificial intelligence, but machine learning or deep learning. But the way they are solving the task, they are able to beat the number on human beings. So that is part of artificial intelligence. Some extent that is machine learning also, but they are not using deep learning. So there is a very thin line between these things. But machine learning always comes under artificial intelligence.
What is the difference between deep learning and machine learning?
Deep learning and machine learning. So machine learning is not different. So again, this is the global set and this is the subset. So deep learning is basically there is one kind of algorithm named which came very recently. This Jan LeCun, I mentioned the name. He came up with this algorithm, convolution neural networks. So I don't want to go into this maths part of this thing right now, but fourth session of his session we'll explain those things. So
it's like hundreds of neurons is deep machine learning. Billions of neurons is
Deep learning.
You go deeper.
Deeper.
I can give an example. I can give an example actually.
How you?
So you have a bot, okay? That bot is lying in the office, and the whole idea is to this should be able to automatically navigate. I just pointed out that you have to go to the opposite corner of the office. Okay, this is just, let's suppose this is a problem statement. So there are different ways to do it. Okay, so this problem statement covers several parts. For example, it should be able to figure out where I am standing, where are all the objects in the office, if somebody is moving or not, and what is the shortest path or maybe the quickest path that I can go through. Okay, so if you consider artificial intelligence, it includes both the things: learning where I am, what is around me, okay, making a decision, following that decision. That's the whole part. Just learning where I am and what are these objects and stuff, environment around me. This is machine learning. When you add this particular information along with the path that I need to follow, and actually following that path, moving from this part to that part, that includes hardwares, motion sensors, motors, and so many other things. That can be considered as an AI thing. Like, you are not just learning things, you are taking decisions, and you are changing those decisions, and you are following those decisions. When you include this complete subset, that can be an AI thing. Plus, as your question, like, what's the difference between the deep learning and ML? The problem that I'm describing here is solved using non-deep learning approaches also. Like, you do not need a completely data-driven approach for this particular problem. People had algorithms. They used to call them SLAM, simultaneous localization and mapping. So simultaneously, at each and every moment, they used to map himself, the bot, along with the objects that lying in front of him. And they used to take a next step, then they used to map it again. So they used to have some sort of algorithm and use this algorithm to go there. But deep learning also has some sort of an, if you are using a data-driven approach, you are just feeding the sensor data. You don't have a algorithm to follow. That can be a abstract way of understanding the difference.
If it's static, deep learning is time.
Okay, deep learning is boring, or how boring that was? History part, history is always boring. So now what are the exciting things happening in the field of AI? So, how many people have used this? Use it, right?
Abhishek is outside.
He was the one who used it.
I used it already.
So, right? So basically, using that app, using that app, you can see that how you look when you are old. If some old person, if he gives that his photo, he'll be able to see how you used to look when you were child. So that is the thing, and so that was done using this GAN. There's one algorithm I mentioned by Goodfellow, this good guy.
Good guy, good fellow.
So his algorithm only they used to. So have you guys realized one thing? So when people used to use this app for all these old pictures, no matter how the person is, the old picture always used to come handsome, used to look like a handsome guy. I found that pattern in that.
Yeah.
Right?
It's called the editing gap.
Better.
The reason behind, so the data that was used for this app, the data was mostly people, celebrity people, or people from this Hollywood. So because of that data, the output was little biased. So if we give our images also, then it doesn't actually look how our Asian people, how we look when we're old. So it was biased towards this wasteful thing. Why it was funny. I didn't get I believe it. And this thing also.
Prisma.
Used it, right? Prisma. There is also GAN. They have used GAN for that. Good guy again. So that the funny things, funny parts, and few of the serious things. Like what are the good things happening throughout the world? How it is changing the society right now. So there is 2018. There was one Google I/O event. So this guy Sundar Pichai, he launched one product, right? So there is Duplex app. So what it used to do, or it has done, so the machine, or Alexa, no, not Alexa, Google Assistant. Right? So it made an automated call to salon and booked an appointment. And the guy on the other side, he didn't realize only that was done something by bot, not some human. So I'll just play that video for 2-3 minutes of it. Are you people interested or it's boring?
The progress of the assistant. As I said earlier, our vision for our assistant is to help you get things done. It turns out a big part of getting things done is making a phone call. You may want to get an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment. You know, we are working hard to help users through those moments. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like, what service is she looking for? Just a woman's haircut for now? Okay, we have it 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day. Bye.
Machine can have humor also. Yeah, so there was one good thing. And then, so this thing happened last year. Not last year, this year only. So this Delhi police, they used this facial recognition system to finally, they found 3,000 missing children who were like abducted or they were like trafficking, child trafficking was happening. So they finally found to locate those children in this home, orphanage home, and they met their parents. So because of AI, and this is, AI can look through walls. So this is another thing. You can use that for your application. I'll show you. So they have one Wi-Fi antenna. So the signal which is bouncing back. So there is one neural network. This at the end of the day, this equation was there, which finally able to find the pattern in this or understood this how the human being works, and based on that, it was able to make a skeleton out of it, the pattern of the work. So this was another cool thing, and then. Using AI, they are able to diagnose diseases, eye diseases. So there is one technique called OCT. In this OCT, actually they get a 3D scan and get a 3D view of the eye, and based on that, from that scan, the doctors used to diagnose the disease. So what they have done, artificial intelligence, they took these thousands of examples of these OCT scans, and they try to predict the disease based on that. And when they finally tested the 94% of cases, it was same like it was like a doctor only. So it was 94% cases it was accurate. Only 6% they are lagging behind. Maybe next 3-4 years, 4 years, we'll be able to catch that. So in that time, for these small things, AI, it will start replacing those mundane tasks from these doctors. And in fact, doctors will only transfer those jobs to AI.
Recently, last week, a app launched that can predict a disease in your eyes in any child. Last week. Yeah.
And this is another cool thing. This is another way this guy, good guy. He has done a lot of good things.
Let's try to darken that up with some cloud. Oh, that's wonderful. What if we were to change all that to rock? Let's try waterfalls by pulling water down from the top.
So basically, it's realistic landscapes.
Wouldn't it be great if everybody could be an artist? If we could take our ideas and turn them into compelling images? This technology allows us to create a smart paintbrush so that if you wanted to create a new picture, you can just draw the shapes of the objects that you want, and the neural network can then fill in all the details. If we add a water feature, the network is able to add reflections, not because we told it that, but because it learned it. Or if we change the ground to be covered in snow, then it knows that the sky also needs to be a different color. I really think this technology is going to be great for architects, designers, people making virtual worlds to train robots and self-driving cars. The input to this model is something we call a segmentation map. It's like a coloring book picture that describes here's where a tree is, here's where the sky is, here's where the ground is, and it doesn't have any details. And then the neural network is able to fill in all the texture and shadows and the colors based on things that it's learned from a large database of real-world images.
I would like to see tree reflecting in that pond.
The real advance here is that we're able to synthesize images with a lot more diversity and more fidelity than we were able to in the past. I really think this technology is going to be great for the dreamers of the world.
No designer here. And there's another thing, so Melbourne traffic police, they're actually using drone and AI power to control the traffic.
Warning. Robots were harmed in the making of this video. This little bug-like robot is pretty nifty at walking.
Okay, for this, I'm about to ask a question. Everyone is silent. Okay, let's ask a question. Every time I start a session, I ask this question. You guys have done math, so you guys know what is a par 0, right? What is a par 0?
1.
How is it 1? Is a question, right? It's curiosity. The idea of identifying what a par 0, how is it 1? Can someone answer? Please try to answer. Exactly the question. So we are sometimes knowledge driven and data driven, right? So this was data driven. We know that a par 0 is equal to 1, but we don't know how exactly a par 0 is 1. So that curiosity part, that is what we humans are, right? That is what defines us or differentiates us from bots, right? The whole idea is humans are curious. They want to find out what it is. So the whole idea of artificial intelligence is to impart that curiosity into entities, say bots. For example, I'll show you I'll answer it later. But you guys can think. It's a simple homework. Say. just want to show how, so as Rubel has earlier showed you a Venn diagram, where there is deep learning, machine learning, what else was there?
Artificial intelligence.
Yeah, artificial intelligence, right? And big data. So you have seen all those Venn diagrams overlapping each other. So there is one more small topic which is not yet, which is very small. It's a small dot right now. That's why you couldn't see it in that, right? There was a small pixel. It's called RL, right? We have seen deep learning, we have seen machine learning, but RL is reinforcement learning. This is where the whole idea of AI is being imparted into entities, right? Machine learning is, yeah, it is data driven, but it is not as deep as deep learning is, right? But whereas reinforcement learning, although it is using a similar computational power as much as deep learning, but it has a different kind of a policy, a different kind of a learning approach, such that we can impart this humanness into other things, right? So let me just show you a small video of how people are using RL.
Warning. Robots were harmed in the making of this video. This little bug-like robot is pretty nifty at walking. But what happens if a mean scientist comes along and breaks one of its legs? Most robots will just try and fail to keep walking in the same old way. But this guy's different. It can learn to adapt its walking style. Just like an animal would, it tries out different things until it can.
So that's the thing, right? So we are just born into this world and thrown into this world. We have figured out how to walk, we have figured out how to stretch ourselves in intelligence, right? So that's how our evolution happened. So thinking about different entities with different kinds of faculty, right? We have hands, we have legs, we have joints, we can bend them. We know what all things we can do. All this because of trial and error, right? So we got some kind of a fruit out of it. Say when there is an apple, although Adam was asked not to eat, he went and ate it. So that was the fruit. So at the end of the day, you are getting something. These are the policies that were put into this, right? The faculty that this guy had were 6 of his legs. He's a 6-legged bot. He could have walked. He could have jumped. He can do a lot of things with that. But how does he have an idea? That awareness that he has that faculty is the question. So this RL that we are talking about, which is actually the future of AI. So people are going to go deep into that further. A lot of active research is also happening in RL. Is that, so they have imparted a policy into it. Fancy term. Policy kuch nahi hai, bas a statement hai, right? It's a statement that was imparted wherein it will get, say, we have dopamine receptors in mind, right? You guys know dopamine? Dopamine is a drug that we have inside. When you are happy or sad or whatever, this is released. Not when you are sad, when you are happy. So we are addicted to it in a way. So that's why we do things which make us happy. So that's how we are inherently programmed, right, in the DNA. So if you look at how its DNA is programmed, some guy, that evil scientist that we are talking about, he has programmed it in such a way that this is the state, right? This is a state, this is a state, this is a state. So every time it exposes or explores a new state, something like dopamine is given to it. We say ki, you have done something good. Beta, have this watch for your birthday. So that's exactly how we have put the policy in it. So it is trying to understand, to get into new states on its own. So it is trying to break free from whatever has been taught to it, right? So that happened. But after that, when it has figured out that it can use that to walk, they have given a policy, said that, okay, if you walk at least 20 meters, or if you cover an area of 10 meters square, in an area of say 11 meters square, you will be given another fruit, right? So it understood how to
Can get
walk
back
around
on the move.
on its own.
Here's what it settled on. It's walking,
But the interesting part is,
most robots will just try.
so the first part was when all of the 6 faculties were almost equal, say without any bias, and they are working fine. But now,
and
when one of the
to keep walking in the same old way.
legs is
But
broken,
this guy's different.
so you can see that it is limping, right? That's what we do as humans. अगर पैर पे फुटबॉल खेलते खेलते मार लग गया है, what will we do? We start limping, right? We try to take more pressure on the one which is better than the other one. But you don't stop using your leg as such, because you know that you can actually sustain with that. So that is what it has understood. It was not told that its leg was broken, it just understood that its leg was broken, right? Because of whatever sensory input it has. It understood that the leg was broken and it started to...
It can learn to adapt its walking style. Just
That's
like
what
an
humans
animal
are.
would, it tries out different things until it can get back on the move. Here's what it's settled on. Pretty speedy.
Right.
In slow motion, you can see this robot's new walk is pretty bouncy compared to its original stroll. It chose this walking style from thousands of options
That's
researchers
that
have programmed into it, and it only took 40 seconds to work it out.
40 seconds.
The robot can adapt to many different injuries. This time, one of its legs has been snapped off. It's not easy moving with only 5 legs. After just 25 seconds though, the robot's back on the move even faster than before. It may seem cruel to this little robot, but robots can be far more versatile if they can get back on their feet after they've been injured.
That's the thing. Imagine this being imparted in the rover that we have sent, right, to Moon. Although it has crash landed, it could have still worked. So that's the thing. This is the most interesting thing that is happening in the RL community right now, which is a pixel, definitely, a small dot. But yeah, there are people who want to create that dent in the universe. And it could come from us. So the whole point is machine learning, deep learning and big data. Combining these things is how we get there. And in order to get there, we have to take these small baby steps of learning this. So the whole idea of this course was that I hope this inspires you guys as much. There is more content, right?
Okay, 10 minutes, 10 more minutes. Sorry,
Oh, yeah.
what I'm leaving.
Nice.
I'm really
Yeah, we'll try to finish it quite fast.
Yeah.
You guys are already bored, right?
No.
Okay, anyway, I'll go on. So I wanted to talk about what exactly we're doing in Vera. Like, you guys know, like, we're doing a shopping assistant kind of thing. Like, everyone knows that. So you would have seen a lot of clothes there. I mean, so we're trying to build that. So I want to talk something like exactly what kind of things we are using. So when we started working on this, so this is really the problem. So we wanted to solve a problem in the fashion industry. You walk in a store, you want to select a cloth. It happens to me. Like, I stopped doing outside shopping because they were very difficult to do. You go on Myntra, you see there's a recommendation based on what you're looking and all those things. So it's very easier for people to understand. So what we saw is that it is a need. It's not right now there outside fashion industry. They're not really implementing that on the store, retail store or something like that. So the problem was that because fashion is very subjective, what I wear, what you guys wear, your mindset will be different. And it is ever changing based on the social trend, what is happening right now. 10 years back, something was there, right now, something was there. So other things, so I say that we were showing that video, right, when a cracker game has some 10 power 20 moves, something like that. So a lot of moves are there. But imagine this is like something definitive, like you know there is 10 power 20 is not, so don't just go by that. So imagine you have to do some 10 step, 15 step or something like that. But this is a very defined thing, you know that. But in fashion, it's very hard to do that. It's because it is subjective, we don't know what is the correct way. Whatever recommendation I'm going to show you, you actually may not like it. Or some people say this is the perfect recommendation I wanted. So that was the problem. Like, we had to take a lot of things in consideration. So yeah, so that is what basically the problem statement was. So I'm not going to read those. Okay, people are sleeping. So this is what we are trying to do. So imagine you work in a store, and then the Vera setup is there. I'll talk about the app part of it later on. So you walk in the store and then you just see a cloth. Imagine you want to buy these kind of clothes or something. You go and hang it on the Vera setup. After that, Vera takes care of it after that. So what we do it first, we get the image and we somehow try to do. So we somehow try to get the image and find out separate the different kind of apparel they are wearing. So if it's top, bottom, whatever it is. It might seem like a very trivial thing. You just draw a box around it. But when a machine is actually doing that, it's very difficult to do it. Like, because there are different kind of pose. People are sitting. Sometimes there's occlusion. You're not able to see the half part of the image. So, and you have seen the funny fashion photos. It's hard to work through it. So this is what it does. So we take the image and then we start getting the top part, bottom part out of it, like a region of interest. So once we get that, so imagine I have that top part, right? Now we were talking about the segmentation before, right? That they generate the segmentation map. Segmentation map is basically, imagine this is the image, right? You generate so you draw a line around the exact body coordinate, something like this, and that is a segmentation map. Instead of drawing a box around it, you draw exact coordinates and then find the segmentation map. So these parts are not there. So when you do a segmentation map, there is an algorithm called Kanan. So we will talk about that later. There is a way to find the color. So imagine if we are just, we crop out the image like a box, and in that box there is this part of that image is there. Say this is the top. Now if I run my algorithm, because of the background and everything and all, I won't be able to detect the exact color, because the background color might also come in the picture. Maybe it's a black background or something like that. So we need to get something like this where I get exactly this particular thing. So nothing is there in the background. So after that, I will be able to run my algorithm only on that part to get the primary color or secondary color, something like this. So this is what we are doing in segmentation. Segmentation looks something like this. So people actually use segmentation for, we have that autonomous vehicle in these people doing, right? Tesla and all those people. So segmentation is the key thing to solve that. Like you have a video on the car and it is seeing the sceneries around it, and it should be able to segment that this is a human, this is a something like that. It cannot just draw a box around it, so because there will be spaces around that. So you have to have a pixel perfect coordination for that. It's something like this. Do you see how exactly is the boxes? So this is the image and then the video footage. This is in roughly how segmentation works. Okay, so after we get the color and we get the top part of the image, so then we have deep learning algorithms to run on that. We will talk about that algorithm later on in the session. So what it does is basically it takes the input of the image. So imagine I have a image, right? It again tries to find a this thing A10 X1. It tries to find a how do I call it, representation of that image. So imagine I have like how do I represent a human being with the names or something like that. So I want to represent this T-shirt with different kind of attributes. It's a, what color is that? Chinese color, right? Chinese color, full T-shirt, then black color, and all those things. But these are very specific. I cannot. Different images have different kind of patterns. So what we are trying to do is through our deep learning algorithm, we are trying to find a very high dimensional representation, say 120-bit representation, 256, which is human being cannot do it. So deep learning algorithm is trying to find some 128 different kind of attributes, which is for that particular top. Human being will be able to find some 5, fashion expert will be able to find 10, 15 or something like that. So we try to find some kind of 120-bit representation or something like that. Then we have the color also, the color of that particular image. After we have these things, now comes the real part. Like I have to show the recommendation. So what we do is I have these images, this particular image, and I have some images in my inventory. Inventory say that we are working for Target. Target has a lot of images in their inventory. So when I hang a cloth, I have to show recommendation based on what is there in the inventory, right? So manually I cannot just sit down and pull some images or something like that. So what we do is we run our algorithm based on these things, like the nearby. So it's like basically finding the distance between 2 points. So I have x1, x2, and you do a Euclidean distance on top. Like we would have already done that, the shortest distance between 2 points. So this is some sort of like Euclidean distance, but it is not exactly. And so this is what we're trying to do. We have these kind of information and we try to sort the image through our algorithm. And after that, the recommendation looks something like this. So you have a image what you are loading, then it tries to find down the top and bottom. If that is available, then it will show, otherwise it will show something similar which is there in the inventory. So this is how the recommendation, this is what the recommendation looks like. Again, I'm going to talk, can you see how many attributes able to pick up? So I'll have some 10 lakhs images in my inventory, which full shirt, different colors and all. Out of that, it has to find out something where the neck matches, where the color matches, where the pattern matches, something like that. A lot of things has to match. So if some person is looking for something like this, he would actually be wanting to see only those information apart from something garbage, something like that. So yeah, the recommendation looks something like this. It's able to find out these kind of patterns. Again, the same thing. I want to talk about this because it might, so you can take a photo actually, photo of things, whatever you want to see, and then you can upload it. It should be able to figure out on its own what is there. Along with this recommendation, so this recommendation we are trying to show from the inventory, like what is there in Target or something like that. Along with that, we are showing one more part of this, which is like social. So social is basically, even if it is there in Target, maybe it's a very old trend, I do not know. And I want to be trendy, I want to see whatever is going on right now in the society or whatever it is. So we show that with this particular kind of images, what is the current trend going on in the market? And what goes nice with that particular apparel. If it's a top, it's what kind of bottom it should, like we generally wear something complementary or something like that. So yeah, so this is how the recommendation basically works. So this is the next thing we're working on. Like, this is something we want to do right now. So this is basically something called virtual try-on. Like you guys would have seen, like where I used to have a product, Gaurav, right, where they could see the 3D modeling of something, right?
Lenskart.
Lenskart. So you guys would have seen that Lenskart application, right? You get to see the specs on that, right? So it's very convenient because you actually visualize yourself, how do you look in that. So this is what something we're trying to do. So like you have an image, this is the image you want to buy, and then we try to find we try to put that image on your body. What you just have to do is, basically you just have to upload an image. It's not like you have to be personally present in the shop or something like that. You just have to upload your own image. So this is what we're trying to solve. This is like we just started to do it. So yeah, I think this is very convenient for people.
Yeah,
This is not our output. This is output.
Again, here also we'll be using this concept of the good guy.
Again, it is that right. So there's a funny story about that good guy. So this algorithm GAN, so his name is Jan Goodfellow. Probably that GAN came from there.
General adversary only.
Right, GAN. So what happened was, it actually came out as a product of a bar discussion, bar fight, basically intellectual bar fight, not like the Texas bar fight. So what happened? He was in a bar, and I think these people are talking about that the computer won't be able to generate something new out of them. Like they'll generally see only the pattern or something like that. So this guy came up, like he just came back home, and then just wrote it in a piece of paper that this is what GAN. Theoretically, it should work. So he started doing GAN. Now GAN has become so popular, you can't stop it. So they started generating portraits of image or something like that. Those fake images you would have seen, right? So those are all GAN made images. It's very hard to detect whether it's a real person or something not real. There's a good application of GAN is that we do that designing, right? Designing of a robot or something like that. So GAN in the future would be able to generate the design on its own. Like you don't have to sit down and write, okay, this is the potentially right design for something structure or something like that. GAN should be able to find out on this way. So GAN is a very huge field. So and
one thing is, so it happened in a bar, right, on beer discussion. So that is another good reason that they should have stopped the Friday.
Definitely, yeah. Not good comes out of that. Okay, so yeah, I think we're going to talk about GAN later on in the course. See, the course is, it's basically we're trying to make people up and running with the machine learning. People, if they do not know what exactly is going on right now in the industry, and it is actually not that a big of deal, you can start there. And I think I've seen a lot of people thinking that it involves a lot of maths, but it is, believe me, see, everything at the end of the day inherently is logical decision you have to take if it goes to that level. Maybe deep learning has more logical decisions. So at the end of the day, like after 1 year or 2-3 years, maybe you would want to dig deeper in the math part, because this is what will take you to the next level. Like you will be able to understand the inherent motivation. What exactly do you want to do? But it's not a thing that you wanted right now. Like when I started machine learning, I did not actually start learning that MIT course or something like that. It's very hard to sit down and do it. But it's a very good thing if you can do it. I'm not telling. So that's what I'm telling. You don't need to know Python about it. This is something you can learn on your own. People learn JavaScript in 1 week through training. So Python is not very So Python is actually more easier than I don't really think that you guys need to know all the concepts. But there's a very great source. I still go to it. I mean, I like that. So this channel I got to know from some other source. So basically he has this nice like 20 videos or 30 videos per topic or something like that. Like, he has the essence of linear algebra. I remember when I was doing it in college, I think in 3rd sem or something, we used to have that linear algebra. Basically solve whatever question is given, that's all. But this guy has beautifully explained what is actually linear algebra, and I think that's what, like when you understand what is in real life, what is actually happening through linear algebra or calculus or something, maybe that will generate a good motivation to start.
Everything.
That is actually everything. You go through this course, no, like beautiful. He is not even talking about the difficult explanation of math or something like that. He is actually showing some animated way, like maybe something like this. Some animated way will be explained.
In this way, the rhythm of counting is kind of self-similar.
If you get time, I would say it's a very good thing to get.
The process.
And it's very small. You don't have to understand the calculations and all those things. Just have a brief idea of what exactly it is happening. So yeah, again, this is not a requisite. If you want to go, you can. So what we are expecting to start with this course is basically maybe start with something with a little bit of machine learning. So these are the topics. I'm not going to talk about these. So these are the topics. Once we feel that we're getting good response from people, I know at the end of the day you have other work, so you won't be able to give good amount of time to do that. I get that point. So to learn something, you have to give some time. So I would say 2-3 hours of effort a week is good enough to really get started with that. The thing is, once you get really interested in that and you see that, okay, there are a lot of things happening and it's not a big of a deal, I can also start with doing that. Then you don't need that push also, you can do it on your own. So that's what we are thinking, that we can help you start with that, and in the way we'll also learn a lot of topics, because when I talk, I get to know I don't know shit about that. So yeah. So we're going to start with machine learning. After that, we are thinking that if we get a good response, we'll probably do something on deep learning. So we would probably start with some classification networks where you generally classify men, women, dog, cat, and all those things. This is very normal. Then probably we wanted to do that project for office, right? Like FaceNet, detecting a human face and all those things. So probably we would try to finish the entire project. Like if you guys are really collaborating, then probably we'll be able to finish it. Again, it's at the end of the day, depends on the response you get. So yeah. So that's all.
Okay, so after this boring lecture, what we have, how many people will be interested to take the coming sessions? So as to raise hands.
सबके नाम लिख लिया अभी से वहाँ जो भी
Okay, so every week Thursday 4 o'clock same time, is it fine?
So what kind of time do you guys want? Like it's morning or evening or like evening? Evening is fine.
4 o'clock.
And the little bit about the kind of the way the lecture will be, we'll talk about a topic and we'll try to give some kind of coding exercise. coding exercise related to that, because when you actually code it, theoretically you'll get to know, you can relate what is happening. Not difficult exercise, very easy exercises and all. So, and you don't need GPU to run all those things. There are online platforms for free for students where you can learn, where you can do these things, processing and all that. And otherwise we have GPU, so don't worry about it.
And it's a one-to-one, so like it should be a feedback kind of a thing. So whatever is going out, that should also come out from you guys. When it is engaging, people will tend to break that inertia of asking questions, and those kind of questions which might look simple or silly inside, right? But they are actually very valid. Like the question that Aditya asked today, that wasn't answered properly actually, but it's a very valid question. When they were explaining about the characteristics, right? These characteristics or attributes that we are finding, it could be anything. Say there was one funny case where we were doing a men versus women. So it was looking at the kind of neck that the dress ka neck jo hai, men usually have collared shirts, right? Women are wearing something else in the data set that we have trained it on. So it was looking at those things and identifying whether it was a man or a woman, as opposed to looking at other features which actually distinguish man from woman. So there is a possibility of machine learning going to some other attributes, right? So that is not what we are looking at. Tomorrow we want to identify a woman who is wearing a shirt also. So that's an interesting question that you asked, because that is a problem that we have incurred, and there are ways in which we can solve it. So once you start asking questions, I guess that will be there. Like interesting things that even we don't know might come into
I
play.
think you guys would have all heard that machine learning models are very racist, sexist. So, there was a story that that it is only recognizing doctors if they are men, and then for all the women doctors it's not recognized as women, but they're telling that it's a nurse. It's very sexist. So later on they were able to solve the problem. They were just seeing that the model is actually seeing not the stethoscope part of it. How would we know he's a doctor? We see the stethoscope generally, right? So model is actually not seeing the stethoscope, it's seeing the facial features of, in that way probably it's thinking that it is not a female doctor or something like that. So yeah, but these are solved problems. People have actually solved it. So right now is that part where it's exponentially growing, and then we do work on stuff which is like GitHub post like 5 days back, 10 days back or something like that. So there is a lot of thing going on I am not emphasizing enough of this, but
every 2-3 days we were thinking about something new, like where we are solving some new problem which is already existing, but we are trying to make it tailor-made to our project, right? So every time we get a new idea, 2-3 days later if we go and look up, that idea is just solved, and somebody has made a paper. Every time we think of putting a paper conference, people are so crazy, they are just doing this. Someone or the other one is finishing that. So it's like that. There is a lot of competition also. It's kind of a good competition also. Like it will be very useful for people to get motivation. That's really nice. And the whole idea is everybody can get started. It's very simple. As you said, there is not much maths involved. Initially, obviously. Yeah. But yeah, we'll make sure there will be a refresher course or anything of that sort. And
if you want math course, definitely. Start linear algebra and calculus, something like that.
Because that's how it is. If you want to like take your skills to the next level, I guess this is very helpful. So you can make the best use of it.
So yeah, depending on your response, we are really hoping good response. Yeah.
Okay, A par 0 is the assignment for this session.
You can try it out right now if you want.
You can.
Yeah,
Definitely.
So take any number, say a square, what is it? We write a cross a, right? And you know any number I multiply 1 with, it remains the same. So if I make it a par 1, what is it? It's this. And basically if I make it 0, it's this. So that's my kind of derivation.
This is another explanation. We need this kind of response. Plot out in a graph equal to fx, and if it is 1, 2, 1, 2, 3, 4, a will be 2, let's keep 2. So this would be 2, and here it would be 4, it would be 8, it will be going like this. Sorry. Yeah. And like if you're going below, like 0.5, that is square root, it will come to 1.44. And the more you tend towards 0, the graph tends to come towards the 0. Like it is at x is equal to 0. This will come at 1, y of n is equal to. And when it goes negative, it goes beyond.
The graph you are talking about, that is
A power
y
x.
equal to x square, but we are talking about y equal to a to the power x.
Y is equal to a raised to x.
But the graph we are drawing,
That's y equals to x square, yeah.
Y is equal to, wait one second. Y is equal to 2 raised to x. This will be, let's put 1 here, 1, 0.5.
We can do it like a to power x equals to y log both sides. 0 will come in front, 0 into.
Log 0.
But my log 0 is there.
But log
No, no.
exactly. It's
0
a
into log
recursive
a
question.
equals to log y.
No, what he asked is, it's a recursive question. So the thing with solving that problem is log is derived from a exponent. So because exponent of a power 0 is equal to 1, log of 1 has become 0. That's how logarithm is defined. So it's, by definition, it's like that. It's like, you got it right. I'll explain.
Got it?
Yeah.
So you're trying to extrapolate it towards.
Yeah, if you tend like x is equal to 0, this will be concurrent at 1.
So there are two methods that people have used here. One was induction. That was induction. You are going from a bigger number and trying to get to a smaller number. And this was extrapolation, right? He was extrapolating from whatever, or you can call it limits also. He's trying to find the limit of, exactly. So he's trying to find the limit of that. And there is one more, for a generic case, right? So that's how we solve problems. So for any generic case in maths, what we do, we just take a generic example. So these are the ways in which you want to find out an answer initially. To find out you're going in the right direction. But say, so we know a power 0 is equal to a power 0. Obviously. So we can write 0 as m minus n. So a power 0 is a power m into a power minus n, which is a power m into 1 by a power n. So irrespective of what a is, unless a is an undefined value like infinity or 0, a power 0 is always 1. So that's the generic solution. Like you can generalize it to anywhere, right? That's it. Awesome. So this is what we expect, right? So if there is that, there are certain ways in which even we don't know how to solve it at times. And you can see some new possibilities coming up. Right? Yeah, that's it. That's all for today, I guess.